Welcome students. Today we are going to start the first part of chapter number 13, magnetic effects of electric current. So in this video the topics that we are going to cover are magnetic compass, magnetic field lines and properties of magnetic field lines. So to understand all the topics, watch the video till end. So first of all, let us see who discovered this magnetic effect of electric current and how he did that. So he was Hans Christian Ørsted, a, a leading scientist of 19th century. He played a very important role in understanding the electromagnetism. So in 1820, he accidentally discovered that a compass needle got deflected when electric current passed through a metallic wire which was placed near to it. Here, this figure shows the arrangement which was done by Hans Christian Ørsted. Here we can see that a wire has been placed near to a magnetic compass. Magnetic compass has a magnet inside it, and when the switch was on and the current was flowing through this wire, the needle showed the deflection, and we know that a needle can deflect only in presence of some other magnet. And here, because no other magnet was present, so he showed that, or he discovered that the electricity and the magnetism were related phenomena, or the wire was behaving as a magnet. And his research later created technologies like radio, television and fiber optics. So he played a very important role in the field of electromagnetism. Now let us understand what is magnet. A magnet is an object which attracts pieces of iron, steel, nickel, cobalt or their alloys. Why? Because it applies a force on these objects. They generally applies a force of attraction on these objects. And these magnets are of various types, but the most common and generally found magnets are the bar magnet and the horseshoe magnet. The horseshoe magnet is of U shape. Okay, and this is the bar magnet. Now, on the basis of the objects being attracted or not attracted by the magnets, the substance can be classified as magnetic substance and non-magnetic substance. Now, what are magnetic substance? These are those substances that are attracted by magnet. Again, for example, iron, nickel, cobalt and their alloys. Whereas non-magnetic substance are those substances that are not attracted by the magnet. For example, wood, paper, aluminium, and there are a lot of materials. Okay, so this were the classification on the basis of the attraction done by magnet. Now let us see the properties of magnets. The first property is the end of a freely suspended magnet always points towards north and south direction. Uh, this helps to find a direction if we are in if people are in sea or in forest. Okay. The next point is the end which points towards north is the north pole, and the end which points towards south direction is the south pole of the magnet. Okay, so on the basis of the direction in which our end of a magnet is pointing, that pole has been given a name. Now, if two magnets are placed together, then similar poles will repel each other. Okay, as we know that like poles repel each other, and similarly, the different poles, that is the unlike poles, will get attracted. Okay, it means if north and north are brought near to each other, they will repel. Similarly, if south and south are brought near to each other, they will also repel. But north and south, or south and north, if they are brought near to each other, then they will attract. Okay, so it means like poles repel each other and unlike poles attract each other. Now this was just the revision of the topics that we have already studied about magnets. Let us see what is magnetic compass. Now it is an instrument consisting of a base and a needle, which is generally closed in a glass case so that it is enclosed in the glass case to avoid any kind of disturbance because of the air around it. It means the needle will deflect only because of the magnetic field. And generally the needle has two poles, that is north and south tip, where the north tip is painted red generally. Here we can see in the figure the north pole is painted red, and this needle gets deflected when it comes close to a magnet and gives the direction of the magnetic field. So this magnetic compass is going to be used for finding out the patterns of the magnetic field lines that we will study later in this video. Okay, so this was about the magnetic compass. Now let's see what is magnetic field. As we know that a magnet has an ability to apply a force even from a distance, but it has a certain region around it till where it can apply the force, and that whole region is known as magnetic field. So the definition says that the space surrounding a magnet in which magnetic force can be experienced is called magnetic field. The magnetic force can be experienced either by some magnetic materials or by other magnet, and because this magnetic field has both magnitude as well as direction, it is known as a vector quantity. We know that vector quantities are those quantities which have both magnitude and direction. The SI unit of magnetic field is Tesla, which is named after an American engineer, Nikola Tesla. Okay, here a figure has been shown in which we can see a magnetic field around a bar magnet. Okay, so this was about the magnetic field. Now let's move to the next topic, magnetic field lines, the most important part of this video. Yeah, so to describe the magnetic field, we need to draw magnetic field lines. Now, what are actually magnetic field lines? These are the lines drawn in magnetic field along which a north magnetic pole would move. Now, what does this sentence means? Okay, this I will explain it later. But let's first let us see a method, that is the first method, to determine the magnetic field or the pattern of magnetic field around a bar magnet. Okay, so what we need to do, first we have to take a bar magnet and we have to put it on a cardboard. Okay, then we have to spread some iron fillings or iron powders around the magnet or near the magnets. The bar magnet is going to apply force on the iron fillings, and because of which the iron fillings rearrange themselves in a pattern. Okay, we can see this pattern in this figure. Okay, we can see a shape similar to a semicircle here on this side. Okay, and here they're going far from the magnet. So these are the patterns in which the iron fillings are arranged. So this gives an idea about the magnetic field around a bar magnet, without which it is invisible. We can't see with our eyes. So by this method, we can get an idea about how the magnetic field is around a bar magnet. Now, from this experiment, we can say that magnet creates magnetic field in its vicinity, that is in the nearby region, and this magnetic field applies force on the iron fillings and a pattern is made, which gives us an idea of the magnetic field lines. Now, to understand or to get a more clear picture of these magnetic field lines, we can perform another experiment. That is, we will be drawing magnetic field lines using a magnetic compass, okay, of a bar magnet. So what is the procedure? First, we have to take a bar magnet, then we have to put a compass needle nearby it. Okay, for example, see here, this is the first position where the magnetic compass has been placed. Now, as we know that like poles repel and unlike poles attract each other, so the north pole of the magnet, this magnetic compass, will point away from the from the north pole of bar magnet. Okay, so here we can see that this is the direction of the magnetic needle. Okay, similarly, then it will be placed here, then here. Okay, and by placing it at different points in the nearby region of magnet, in this nearby region of this bar magnet, the needle will keep pointing in the different directions. Okay, and on tracing all these points, for example, see, the north pole of magnet will attract the south pole, and and on moving the compass needle slowly and mark the points, means we have to mark all the points and the direction where the magnetic needle was pointing. So on joining all these points, suppose it was pointing in this direction, okay, then at this position it is pointing in this direction. So on joining all these points, we will get a pattern which gives the direction of magnetic field lines. Okay, and this can be done for the both side, even from the upper side and even on the lower side. So on doing for all the points, the overall magnetic field lines obtained will look like this. Okay, so what we can say, we can see here that it is emerging out from north pole and it is entering towards the south pole. Okay, so this is how the magnetic field lines looks, and this is the direction. So let's see few properties of magnetic field lines. The first property is magnetic field lines originate from north pole and ends at south pole, but where from outside the magnet. Okay, this is the direction for the magnetic field lines outside the magnet, but in but from inside it moves from south to north. Okay, it is shown here, an arrow shows that the magnetic field lines in the inside the magnet moves from south to north. So what we can say that see, this is the it is starting from north pole, reach south pole, and again from inside it will reach the north pole. So what we can say that it is a closed loop. Okay, it is a closed loop, and the magnetic field lines come closer to one another near the poles. Here we can see that in this region the magnetic field lines are more closer to each other at both the poles. So they are closer near the poles, and they are separated widely in the other regions, and magnetic fields do not intersect with each other. This is a very important point. Okay, the magnetic field lines never intersect each other. Okay, why? Because if suppose magnetic field lines intersect each other, then it will show two directions. Like in the previous figure, we saw that if suppose a magnetic compass is placed here, so of course it will point in this direction, which will give the direction of magnetic field lines. And in case if magnetic lines are intersecting, suppose there are two lines, they are passing like this. Okay, they are passing like this, there are two directions at this point. So if a magnetic compass is placed here, then the needle can point in two directions. Okay, it will point only in one direction. So this shows that it it points means the magnetic field lines do not intersect each other. Okay, so this was about the properties of magnetic field. So that's it. If understood, just type yes in the comment box, and thank you for watching.